to improve the machine safety as our side. And the next one, I will share the agendas today. First, Banjob will share for of you about the ISO standard. Some theories about the POR. POR, that's mean the performance level requirement. And the next Banjob will share some the practical example. And after that, I and Sean will share about the groups machine safety standard requirement for the POR and cartology based on the risk level. Okay, now it's your turn, Banjob.
Okay. So based on agenda here, I will try to follow. I also prepare some agenda from my side. I prepare by myself around almost 2 days for the presentation because I just worry that plenty about the language boundary and then.
So Banjob, I think today maybe we just our only. So if in the future, sorry, you hear me?
Yes.
Yeah, but Banjob, I think we should follow you because you are expert in it. So maybe today we just go on road, and if you need go more the detail in the future, so you can visit the Vietnam, so we can organize one workshop, and some the children will come to Ho Chi Minh or some come to the some plant, so we can go more detail for it. Yeah.
So I will try in the presentation that I have prepared now. The presentation almost 100 slides, but most of slide we can go quickly. I will go in details of the POR and also the safety device and also the categories. So once you understand about this, we can have face-to-face session at the site. So I can go to the site and then do the assessment for your system. And then we found if we found some gap, we can plan for action plan. Is it okay, son?
Yeah.
Yes.
Yeah.
So I will share my screen now. Don't worry about the number of slides. I just extract from some information that I have and also from some online. You see my screen?
Yes.
Okay. So just some people that don't know me, my name is Banjob. I'm from Soviet Asia team. Currently, I'm responsible for both role. The first role in the regions. In the region in Southeast Asia, I'm responsible for automation, to support the project, to support the safety, to support any activity related to the control system and automation, as well as some electrical design, or when you have some CapEx projects, I will support you. And also for Industry 4.0 in the regions in the same in Southeast Asia and in APAC, Asia Pacific, as well like China or Japan and Korea, I support Industry 4.0 as well. And another 50% for myself, I also support for gypsum worldwide. That means every regions in Europe, in America, in South America, in Asia Pacific, and also some part of in India as well, for about the Industry 4.0 part. In conclusion, that about automation, I'm responsible for Southeast Asia regions only. So for today, the content of today is I will explain you. I would like to call sharing session because this is not a training. Training is more in details, but for me, it's sharing what I know. I can share to you, and then I can come to your plant face to face, and we can walk through the machine together, do the assessment, and then we prepare some action plan from the gap that we found. Any questions so far? So today, You mentioned about the control system for machine safety. So when you talk about the machine safeties, both part, machine safety for the machine guard or mechanical part, but for today we will mention about the control system for machine safety. How you design the control system to make sure that you minimize the risk to the people who work with the machines, and also to protect both people work with machine and protect the machine to run in long term. Have you mentioned about the performance PLR? We call required performance level, or some people they might call performance level required. And second part is about the safety component or the device. I think this one most of you already know, but I will mention again. And last but not least, about safety categories. Because when we start with a safety performance level, this one, they will mention that the safety category about the circuit, about the capability of the device or the circuit that you design or you use for the machines is meet the PLR level. Start with PLR level. So agenda today is three part I mentioned. Starting with the regulation, this is from the GMT document. They mentioned about electrical regulation regarding to the safety system to comply with the design. So the first one, they mentioned IEC standard, safety machinery 60204, that one, safety machinery for electrical equipment of machines. The second one is they mentioned about the EN ISO 13849. That's one. Or IEC 62061. This is for safety of the machine. This is we focus today, safety related part of the control system. And they also mentioned about the safety of machinery for emergency stop equipment as well, EN 481. So what we mentioned in the category today, they mentioned about this one, ISO's 13849, about the control system part. So starting with the required performance level. What is the required performance level? I think this is the wording. Normally, I can conclude that this is the way that you do the assessment at the machines, how much risk at the machines. Once you got the how much risk, you know the level, you will get the required performance level. Normally, the machine, they have the performance level, but required performance level is mandatory or to reduce the risk of the machine that can link to the people who work with the machines. So that's mean we call PL and then R, PLR. Normally this one we have level B, C, D, and E. A is lowest risk and E is high risk. I will move to the example. If the robot like this is the small, slow-moving robot. They mentioned this one is low risk, can be A. But if you work with the high-moving, for example, in HPC, they have one robot for the board classification, the reject board classification, reject or good or something like this, classification class of the rejects one. So this is the high, we call E. In the next slide, why we should care about the performance level? For sure, everybody know, because we care about performance level because of the risk of the people who work with the machines. We make sure that the people or employee who work with the machine will be safe, and when we have to reduce the risk based on the design of the control system that we are designing, and also to make sure that it's safe, reliable, or to improve the machine productivity as well, to reduce the machines stop. And the level we call how to regarding the ISO, as I mentioned, 13849. The level, the how to start determine the requirement, the PLR. I will call PLR. They have the three, I can say, the three level that the three group you have to do the assessment. The first one is severities. You can say this is how serious of injuries if the accident happened because severity. And second one, frequency or exposures to the hazard. How often you have to come to do some activity in these machines or in this area? How often? We can have slightly, this one seriously slight or serious. And this one frequency seldom means just sometime in a month, but frequently that means in one day you might have to come to this area very often. And the third one is about the possibilities to avoid hazard. Do you have possibility to avoid the hazards? You have not much. If not much, you can select P2. If yes, you have some specific condition, you can select P1. So you have two choice in each question. Let us say severities, how serious you have, S1 or S2. I think missing S1. This one should be S1. S1 and S2, F1 or F2. You can more understanding in the next slide. In this slide, from the wording, convert to the picture. You start from here. Can you see my cursor and my mouse? Can you see my the mouse
Yes,
cursor?
yes.
Okay. So starting from here, the definition I explained earlier here, you can see here, this is definition. That means if you move up, that means lower risk or lower rating can be. For example, if you start the first one that they ask question, how serious of the incident if accident happen. You said this is S1 is like normally not much, and then you can select S1. You go to S1, and then after S1, they will ask you again about the same questions. Even either you go to S1 or S2. About the second one, frequency or exposures to hazards or exposure to this area that you mentioned. For example, we are going about the takeoff area or wet end area in the gypsum board. How often you have to come in to have some activity inside the machines? If you say not much, you can select S1, and you say, oh, a lot, you can say S2. And then second question, they will ask you again frequencies. So sorry, the first one is serious. The second one is frequency, F1 or F2. F1 is not much, F2 is a lot. And either you select F1 or F2, they will ask the same question again. For example, you mention S1, and then you answer F2 here. Not you have answer that this is we come to this area a lot. And then for the third question, they will ask you about the possibility of avoiding hazards. If you say you don't have nothing to avoid hazard, you have to select P2. You can see here the low risk is higher on the top of the triangle, and the high risk here. Any questions so far? All right. If no question, I will move forward. This is example. This is example of from the chart. Severity, and this one is probabilities. Starting from severity, how serious of the if accident happen. You start with. It says using your corresponding parameter on the chart below, you can determine required performance level. For example, severity of injury slightly. You start with S1. If injury is slight, not a big injuries. If you have some accident there, you can start with S1. But if serious, every time serious, you have to move to S2. And also, to choose between F1 or F2, the second one. If the frequency or exposure to hazard is frequent to continuous, so that means if more frequently to continued, uh, you have to come to inside the area very often. You have to select F2. But if not much, you select F1. And also the third question, you ask about P1 or P2. If you say that this is it is scary, I can say not possible, that means impossible to avoid, and sometimes it is not easy to avoid, limiting harm. So you select P2. That means this one is you can think that you can remember that if 2 that mean higher, 1 that mean lower, something like this. Serious higher, select S2, and probabilities if both frequency and also the how to avoid the hazards. If you said this is very low, okay, low chance, you can select this high risk, that's mean P2. So this mean 2 that's mean higher risk, 1 that's mean lower risk for you. Any questions? And here, if you heard about this another standard about IEC 62061, they mentioned about SEAL, another IEC standard. This is I can say equivalent. If you have PLRE, that means SEAL 3. D, that means 2. They also have another chart about the category. So I will mention after this. And also this one, you might have this probability of the dangerous failure per hours. You can see here as well. And this is example. This is example in new area. Two example in this slide. The first sample is they mention about the case 1 bucket elevator. So bucket elevator, anybody don't know about bucket elevator? Bucket elevator. When you want to transport the gypsum, let's say, or the gypsum or the stucco from the ground level to the silo over, I guess, around 5 meters or 7 meters, the silo on the top. You can use one of the transportation, the material transport from bucket elevator. This is have the bucket chains. I'm not sure how to call the bucket one to bring the conveyor, the material to the top. So this one, most of the part inside the machine guarding. So this is they call bucket elevator. So for bucket elevator, they need to prepare for the emergency stop, let's say, for emergency stop. And then they have to select the category. They have to select the device equipment component for the ESOP component. So they starting with the risk assessment by using the performance level required. So starting from here, they mentioned the severity of the process of injury. They call S1. S1 means not smart equipment is fully guard, no risk, not much risk. And then the second question is frequencies. They mentioned this one also F1 because no exposures. People no exposure to this the moving part inside. Chat exposure is a shot during the maintenance only. And then this one they consider F1. And the third is about the third question, possibility of avoiding the hazard. They mentioned this one, so this one is possible to escape. So that means they mentioned this one is not possible. So they mentioned P1. So what is the rating for PL rating for bucket elevator? Finally, what is the rating? I want interactions. I don't want to speak only me and then keep silence. So the answer is what is the rating of the bucket elevator risk assessment? If you want to to design for the ESOP. Hello.
Yeah, we hear you, Banjob.
So I want the answers from the student, from the attendants. I don't want to speak only one way. I want to read some answer from the participants. So my question was about what is it the rating for bucket waiter after we did this assessment here. I don't want to hear from you, son, from other.
Hello.
Okay, if no
Hello,
answer,
Cường, level của máy.
Okay, we move to next slide. And case 2. This is the high-speed inertia fan. We call cage mill. This is the big fan. Big fan, they select S2 because the risk of death if people can get into the fan. Something like this. And then they call S2, risk of death. And then second one, frequencies. They said very rare because F1, they select F1 because very rare because of the equipment fully guard inside. And for P, they select P2 because the fan is high speed fan, difficult to avoid hazard, they mentioned. So select S1, F1, P2. That means the rating, the performance level requires D for the high speed inertia fan, cage mill. But for the bucket elevator, the required performance level is only A. So that means from here, we have to design the control system of the safety interlock. We select the category and also the component or device based on A level to meet A level. And for this one, must be D level. Or you can design E. So you will see another slide. From here, the first one you define the performance level required first. The second one, the second is select possible category. From the case number 2, you got D. The case number 1, you got A. For the case number 1, A here, and this one is you can select. You can see category B, category A, category B 1 until 4. I will explain about category after another slide, so you will understand what category mean. So this mean, for example, if your performance level require A, this mean you select you can select category B, logic the circuit there, the circuit for the safety. And if your PLR is D, you can see D, you can select either from category 2 until category 3, this one, because they have the range. So from here, you can select based on your risk. If you select higher, lower risk for your machine, for your people, but you can select category 2 as well because D, like this. This one is MTTF, is mean time to dangerous failure of the component. So if the mean time component to dangerous failure, D is dangerous. Now MTTF is mean time to failure, but with D we call mean time to dangerous failure of the component. If the mean time to failure of the component is very long, you can select based on this. You can see the photo. If very low, if the mean time of the dangerous failure of the component low, you will meet only category C. Let's see. Even you select category PL level C, But if you select category 3 of the safety circuit, you will meet only if you use the low, okay, the low number of the mean time to failure of the equipment. You can meet only level C. That means if you want to meet D for the PLR here, you need to select something like this around this here. If you use category 2, but you need to select this one is higher, the MTTF. So MTTF, I will not mention anymore. I will mention here. But after this, I will mention about the category. Because performance level, after you did the assessment, you come to this chart, and then you select. If you got E, that means if you got E, you can use category 3 or category 4 only. You cannot use the lower category. For category, I will explain you more in another slide. From here, you have any question before moving to next slide?
Anyone have the question? I think you can use the Vietnamese to ask.
You can ask Sun or Tang, and then Tang can ask me. If don't have, I will move to another slide because we don't have much time. This is for another application for this is wet end and takeoff area. If you can imagine, if you went to the parcel board line before, we have wet end and takeoff area. I think this is forming belt. It's the cutter here. And then I'm not sure where is the cutter. So the cutter here, and then this is wet end area. This is reject area. And this is cross conveyor before go to dryer infit. Is it the dryers? So from here to here, the moving part, the rotating machines, really dangerous for the people. So most of here, you put the fence here. And the fence, you also have the micro switch, if you remember, right? In the micro switch. So come back to do the how they do the assessment, how performance level required for this area. So safety fence.
Sorry, Banjob.
Yeah.
Kèm này. Đó đây.
I would have the question related to the safety device applied for the safety zone. In the Vietnam at the moment, some plant they apply the safety device like the sensor and the equipment already installed the fan also, but they still install the safety sensor. So my question is when we should apply the sensor safety. If we have the fence already, we need to install the sensor or not?
If people have to come to inside, example, to clear the jam or to do some adjustments sometimes, I think you have to install micro switch, for example. But if not often, just only maintenance only, and then maintenance, you can use your special your tools to disassemble the machine gun and then come in. If you based on the people, if they want to come inside during the production, example, to clear the jam or something like this, this is require the micro switch or the sensors. Normally with the machine guard, they can modify to have the micro switch. I can show you the type, some micro switch after this. So micro switch they need if they have to come inside the fence to clear the jam or to adjust the machine frequently. Let's say maybe one time per day also need. But if only the maintenance time, you might don't need the micro switch. But if you need to come inside, you need to make sure that you need to apply per the standard to have the micro switch. And for this area, this is more special because very dangerous because the PLR level is E. So they select category C, and also the lockable micro switch. But some area you don't need lockable micro switch, but in Saint-Gobain standard for the moving parts like it, they need the lockable micro switch because the inertia of the machines quite high. Sometimes when you open and the machine stop, and then they might need some lockable micro switch. In conclusion, so based on the how exposures to the machine to the area inside, if not much, you don't need the micro switch. The fixed guard is can protect the people come inside. Normally, fixed guard is the I can say very safe but not convenient. So if they put the fixed guard, it's very safe. This is for sure. We can protect people cannot come in, and the people I can say body cannot touch the moving part. But in reality, the fixed guard is not suitable for every situation because people need to adjust the machine, people to create a jam, machine jam or something like this. That's why we consider the control system like this. What we are talking about, the PLR. The PLR is to link to when you need the micro switch or you need the emergency stop or the pull wire switch. What the risk level that you have, and then you can design the circuit or device, select the component of the safety component based on the risk that you have. But if you have the fixed guard, you don't need to learn about this. You don't need to learn the PLR because PLR will need when you need the micro switch, you need the rope switch or pull wire switch, you need emergency stop to stop the machine before you enter to the area. Or emergency stop is just emergency case, unforeseen. Machine must be stopped immediately. But if you put the fixed guard, we don't talk about the control system. We talk about mechanical part to protect the people. This is very good to protect, but most of the plant they don't want only machine fixed guard because they have to operate the machine. They have to come inside to clear the machine or to adjust during the normal production. Based on the risk, we identify the assessment or the PLR, and then from PLR, we select what category that we can use. Is it clear?
Yeah, I'm great. Yeah.
So they mention here high risk in the within area. And then they select this one PLE. I think they have example as well why they select E. Yeah. This one is PLE and category 3. I will explain in details. From here, you remember about this, right? S1, F2, F1, F2, P1, P2. If 2, that's mean for sure high risk. High risk. So you can see triangle here. If you go to the bottom, that means higher risk for this machine or for this area. So for wet end and then take off, they consider high risk because of they consider the severity of possible injury is H2. They mentioned that operator had to access to moving part like conveyor and turnover arm. Risk of I'm not sure what does it mean what does it mean, son, in safety language, this one, irreversible injury. So that's mean this one high risk to operator if they come and then something happen to them. And if it says this one is frequency is exposure to hazards, high frequency, regular control of the machine by operator. They have to come inside to clear the jam or to control something inside the area. They said this one is F2. And third, possibility to avoid the hazard. They said this one is very difficult to avoid the hazard. So they consider P2. That means PLR is required, E. So once require E, for E, if you remember this chart, E, so that means E, for sure, you need to select category 3. So I will explain in more detail about the category between each category. They mentioned category B, category A, C, 2, 3. The maximum is category 4. And this one they mentioned PLE, PL level require E, level E is equals still 3. You can search in Google what is SIL, standard for safety. If we explain. So this is the first one about the performance require performance level require or require performance level. I will move to the next topic, the safety component. It's okay. So this is the safety component. Anybody don't know about what I mentioned here? This emergency stop, put button, safety macro switch, light curtain, pull wire or rope switch here. Anybody don't know? Please raise your hand. I assume everybody know about this equipment.
Pull wire.
Because pull wire. Pull wire is rope switch. Example for the if a gyprock plant, you can see for, I think, for the forming belt, right? I'm not sure they have forming belt along the line, the conveyor forming belt, and also from the rock crushers, long conveyor belt, they also have this one. And in HPC and VTI, I think they have this one for the I can say AK line, the laminating and also the decorating board line. They have this one along the line. They call pull wire or rope switch. Normally this one, we need the model that when we pull and then lock, and then we have the button to reset this one as well. And some gypsum plant, something like this, really long, and then you can pull to stop the motor. And next one is about the safety relay. Some plant, they might use safety relay. Example is this PILZ and 6. Some model like this. Have you ever seen before safety relay?
Yes.
Okay. And if you don't use this one, some plant like a gyprock in Haiphong, in Ho Chi Minh City, in some machine, they use safety PLC. So the safety PLC from this is Siemens. The catalog number, you got this one, catalog number followed by F. F mean how can I say, the flow fee. They use the F mean for the safety PLC. If without F, it's normal PLC. You cannot use for the safety PLC. That means if you use this one, you don't need to use this one. And then this one will connect to, for example, for the Profinet, they call ProfiSafe network, and then connect to the I/O card here. The I/O card here, you can see the yellow color. If this is normal one, this analog output. But if the safety input output, you will see the yellow on the card. So let's say this is fail-safe analog input, fail-safe digital output, something like this. We call safety PLC. In Haiphong, we use a lot. In Ho Chi Minh City, in mixers, they have. But other area, I'm not sure. But in mixer, they have. But in VTI and HPC, I'm not sure they have. I think they don't have this one. They have this one a lot. Am I right?
Yes.
Okay. So this one is, you need to do the wiring from where? From the component that I mentioned here. This is the component wiring, like an input. to the safety relay. And this one also input to safety PLC input onto this. I will show you the diagram from our standard. Come back to the safety device. This is safety relay. When you got the PL rating E, and then you select category 3 Z. So example of the model of the PUs. This is the the safety relay for emergency stop. They call emergency stop relay. Only one safety relay for emergency stop purpose. In the data sheet, they will mention safety related characteristic data. So based accordance with the ISO 13849, and then they mention that this one meet PLE and category 4. That means if you consider to choose category 3, but this one can meet category 4, can you use this device?
Yes.
Yes, exactly. You can use this device because this is higher, right? So you can use this one for any PL level, performance level, because this is the highest one and meet the category is highest category. That means you can use even your PLR A, B, you can use this one. But for sure, for category 4 or PLE, you can use this one as well. Another one is about another example. This one in EN 954 category 4 meet in each standard. You can check here. So that means when you design and you select you want to buy the new device, especially for the safety PLC and this one, this is like a intelligence relay, not same as normal relay. Then they mention about this one, category 4. I will explain you in details why they mention about category 4, what special feature that this safety relay they have, not normal relay that you have in the control cabinet. Another equipment, this is isolator. In Saint-Gobain, we have local isolator in each motor up to 73 kilowatt. 76 kilowatt, because, and I think the higher than this they cannot because too big as well. In each motor, you can have in each motor here, but for the bigger one, you can do the, again, the disconnect at the control system, the control panel of the MCC. But this one, we call the local isolator. Have you seen it in your plant? Have you seen before?
Yes.
This one, this one, just in case you have the maintenance and safety switch. Example, you want to do lock door. This one, you can put the key to lock. And you can see here as well, the test button here. This is the key switch. You put the key and then you select to turn on and then automatically back. Turn on and then the spring to return back. So this one too, like a put button, but they use the key switch. Normally in the normal run, you don't need to use this button. Just only before the maintenance. For example, you did the lock door. You do the lock door at the here. You need to ensure that motor not rotate. Once you lock door, you need to test first. You test from here. And then another purpose is when you turn on, you want to jog the motor. You can test from here as well to jog the motor for a while. But not only for jogging, for testing. I mean, testing both when you turn off the lock door, make sure no power here when you press start here. And then when you want to start, and then you test jogging the machines. Any question? And this is the example of the circuit diagram. When you select the right safety relay, this is example the circuit diagram. This one is category 3 circuit diagram. You have for emergency stop, this is emergency stop. emergency stop. And then each emergency stop, you have 2 NC. That means if you don't press, this one will be closed, both contact closed. And this is in series. If you have many emergency stop, you can connect in series and then connect to the micro switch. The circuit based on the model of the safety relay. This is just example of the model from Schneider Electrics. You have to learn from the user manual how to do the wiring for the micro switch. This is example for the Weber plant in Myanmar, this one. So they have this one. Normally, you can see here, this is the we call redundancies, 2 contact. And this one we call redundancy as well. They have double contact inside the safety relay, and then this one to control the magnetic, or the magnetic contactor to control the motor power. Another sheet. This is safety relay. This is the micro switch proximity 1. They have 2 contact as well. And this is for the Gibraltar plant. They use the safety PLC. For safety PLC, the wiring quite different, because when you have the emergency stop like this, they have 2 contacts. So both 2 contacts, you must do the wiring to the safety PLC input 2 point, input 1 and input 2, two cable for each contact. And for the output, they also have the output, this one they call redundant output, and connect to the contactor, this contactor outside, redundant as well. And also the redundance of this one, they have the interlock to the VFD here. All of them you can see interlock. Normally safety PLC can meet category 4. Category 4. And this is another example. This is the emergency full wide switch, and then full wide switch connect to the safety PLC. And then this is the main magnetic contactor of magnetic contactor. This is the isolator. Isolator must connect after the contactor, right? The magnetic contactor. This is isolator, local isolator. This is the motor. This is the motor breaker with the overload, and this is the circuit breaker. The magnetic contactor, the main magnetic contactor to control start and stop DOL of the machines. So they put this one. This is the once this one pull wide switch is open, and signal come to the safety PLC. Safety PLC send the command to open the safe output, and then safe output will control the power, the cut the power of the contactor off, this one, and then this one will be stopped. And then they also mention about MTTFD, as I mentioned earlier. So you need to check about the MTTFD about this one, because this one related to the PL rating as well. And this is example of circuit I mentioned about the category. So this is the draft mentioned I will have in details. Category B, the example, they have category B, 1, 2, 3, and 4. This example, they don't have example category B here. They have example category 2. Category B, I will explain another slide. So for category B, that means if you design your control system meet the standard of control system without any safety device, that means you meet the category B. Normally not safety standard for category B. But category 1, everything the same, but you select some device meet the safety standard. For example, MTT FD. You meet the highest, the longer lifetime of the equipment, and then you meet category 1. Normally the circuit, everything the same, but just the difference of the equipment. And category two, you have something to monitor, like a feedback loop from the magnetic contactor to make sure that when you create emergency stop and then the circuit breaker open, but no redundant system for category 2. But for category 3, you can see double input, double output, everything double that we call redundancies. And also they have the monitoring system like this as well. But this is category 3. But for category 4, they will have some intelligence features inside the safety relay or safety PLC. They can check any fault that happen in the system and then make sure that machine in safe state. So you can design with safety PLC or safety relay based on your budget, based on your convenience. So I think this one example of the circuit. The third one is about safety category. Any question now? What time is it now? So the last topic about safety category. This is very important. I think after I mentioned about the PLR, required performance level or performance level required, and safety component, what you need to check when you select safety component, what type of safety component. And I also mentioned when you got the PLR, you got the performance requirement, what level that you need for the machines for this area. So they mentioned about the category. So number 3 is about the safety category. You need to understand why we need category 3, why we need category 4, based on the risk. If higher risk, you need higher category. If low risk, you don't need higher category, but you can use equipments or logics. You design your selection of the equipment higher than what the performance level required is good, but we cannot select lower. Safety category. So I collect the information from this video. If you want to learn more about this, I keep this original from his name is Kevin McDonald, Industrial Control Product Managers. So he explained about the safety category very clear. I just captures from his video because I try to look out. I don't want to, how can I say, a lot of wording without any explanation or something like this. So that's why I got this video, and then you can play by yourself this video when you got this slide, and then you can replay what I mentioned now. And then this is I keep credit to him because he generated this one. Starting category B. Category B, we got you mentioned the diagram here. You have this is the fuse. This is the I'm gonna say the contactor. This is the overload, the contactor and overload, and the motor. And this is the start button. This is the stop button, and this is the contacts for stop, just in case you open the machine guard here. And then this is the coil of contactor. This one K1. We have K1 here. Start, when you start here, machine motor will rotate because of contactor will be cross the circuit, and then motor will be start. Once you press stop here, this one will be power will be off, and then cut off this power, motor stop. And then for the stop, you can stop here, or you can stop by open the machine guard because they have the mechanical or machine guard and contact to open the circuit. Anybody don't understand what the circuit I mentioned here? Do you understand? This is the simple diagram that they use to for explanation. We will use this one after as well. make sure you understand this figure, these pictures. If you don't understand, let me know. If you are electrician, electrical engineer, automation engineer, even some mechanical or mechanical, they understand. This is the simple, the motor control circuit diagram. So for category B, normally category B, they mentioned that safety rated part machine control system that meet the design standard. But normally this one is they follow everything per the control system standard, automation standard. That's it. Don't think about any I can say, don't think about the any safety category 1, 2, 3. Don't think about this one. So all the component, if rate that category B, you don't need to buy the safety device. For example, you for the safety relay or the component contactor that related to the safety. So category B is lowest one. We can say this one is to meet the standard. This is enough. This is category B. If you design your control system already meet the standard, you already meet the category B. This is, I think I move. You can read by yourself. I explained already. And the configuration of category B. This the picture here and here the same. I already explained. If you don't understand, this is category B. And for category 1, exactly the same as category B, but your component that you use, you consider component that meet the safety standard. Like example about the MTTFD. You mentioned about MTTFD is higher MTTFD number. That means you consider about the long lifetime, more reliable equipment that related to the safety. This is category 1. Everything the same, but just consider the higher safety component. They call well-tried safety component and safety principle. This is the beginning, starting of the safety category. Any questions? They can say safety rated component. Well-tried mean safety rated component. This is if every circuit diagram same, but just only the component are different. I mentioned already that this is category 1. You remember this one, and then I will move to category 2. So this is another slide compare about the category B at category 1. What different? Everything the same, but just only the safety components. As I mentioned, standard electrical control. This is just meet standard, no safety component. But this one, the safety component there. If you want to do the machine micro switch to like emergency stop, when you open the machine card, you need to select everything about the safety equipment. But this one you don't need to consider. Next is category 2. Category 2, you can see is they have the safety function. Shall we? The check of safety functions. They have the feedback, but check must be done by the people regularly, periodically, not the system. But the system can be lost of the safety function as well. From here, you see something different. The equipment, you can see this is safety relay. For category 1, category 2, you don't have safety relay. But they consider the high reliability in category 1. But category 2, you're starting with the safety relay now. You see here, safety relay, they have redundant. This is the relay output, the output relay from the category. This is the input to the one micro switch connect to the safety relay, and then once this one open, this one will be open. And then for category 2, you have this one, monitoring system. For example, when this one, everything is okay, if you start the machines, this one will be open, right? This one will be open. But when your machine stop, they make sure that this one is, okay, I say, stop. Or we call the feedback system from the contactor to tell the okay, I say, the safety relay. Normally, this contact we use for the reset functions. Let example, if machine stop by pressing this emergency stop or machine got open, and then this one will be open. This is the coil, and this is the relay of the this one, and then interlock with the control circuit of the contactor here. When this one open because of this one, and this one will be open because K1 command this one open, right? And then once this one open, this one will be open, right? And then you reset when you move this one back, this one, and then restart this one, contactor will be start back, cross the circuit to run the motor, and this one will be open, right? This one will be open again. Oh, and this one will be sorry, this one is this one will be open when this one close, and then this one close when this one open. So this one will be closed to reset the circuit before you restart the machine again. So for category 2, they just have this one component, have the safety related specification for the safety and have monitoring, but only one channel. They don't have double channel or redundancies. We call this one is category 2. In category 2, if you have some fault in the system, category 2 cannot detect for every fault. What does it mean fault? For example, if you have some fault of the welded contact, I will show you the fault after this. So category 2 is the starting of the safety circuit, safety device, and you can consider this starting one. But if serious one, you have to consider category 3, category 4. Any question? I saw question, Tom. I think I saw somebody raise the hand. Question?
No, I don't see.
No. Okay. The third and number 3, we got category 3. Category 3, you will see some category 3 is they can detect the fault of the system. The fault I will mention what fault you have. I will move to the category 3 example. You can see what you see different category 3. You will see this one is redundancy, right? Double contacts. This one double contacts here, double channel here. And this one also double contactors here, double contactor. So we can call this one, they have redundancies. Redundancies for like a backup system. This is the backup just in case another one fail, another one can make the machine in safe state. We call this one is redundancies. For category 2, they don't have, but category 3, they have. They can detect the fault in the system. For example, the fault. For example, you have the welded contact of the input here. This is one fault. This is one fault. And another one is normal. When you press this one open, but this one open, this one not open. The safety relay will know, and then we will know that open only one contact, and then the safety relay will get the fault like a red blinking, and then you need to check what kind of fault related to user manual. And this one is welded contact not open, just open only one. This is not, we call detect the fault in the safety system. So some kind of fault like this, the emergencies are the safety relay in category 3, they can detect. That's why intelligence relay, not normal relay. They have the system to check. Something like this. And even you have the short circuit from one channel to ground, the system, the safety relay will know and getting to the fault. And then once getting to the fault, they will cut off the power to contactor of K1 and K2 and open circuit of the motor. That's mean we call in safe state. Safe state. If cannot cut the power here, the motor can be start a continuous running, continue to run. This is not safe state because we want the machine to stop immediately but not stop. But in some case of the category 3, they will have some gap of the we call the double fault or called accumulated fault. After first fault and accumulated fault, some case category 3 cannot detect, but category 4 can detect any fault, every fault. But category 3 they still have some gap. But most of the plant, most of the control circuit in the world, they consider category 3 around 90% that I have seen, and as well because of the cost, because of the risk reduction, the risk level, the optimum selection, they select category 3 with redundancies. But if they go for category 4, very expensive for them. Category 4 is the verdict. In category 4, they can detect everything they repeat from category B, 1, 2, 3, and then they mention that not lead to loss of safety function from any accumulation fault. I will show you what accumulation fault. This is category 4. Everything the same, right? Nearly the same at category 3. But the safety relay more intelligence. They have some pulse. I will show you in another slide, a pulse to check one by one, channel by channel. The pulse is not the same duty cycle. Okay, the same time. One pulse, the first pulse to check channel 1, another pulse to check channel 2, all the way to make sure that every channel is okay, every contact is okay. They have the pulse to check. That means if any fault happen, they can detect. So I will explain you about the fault, the 5 type of the fault. I mentioned about the fault for the safety circuit, safety category, because this one very important to understand. If you understand about the fault, because each category of the, as I mentioned, they have limitation about the fault detection. In category 1, 2, 3, 4, 5, 1, 2, 3, 4, they have different features. Category 4, they can detect any fault. The first fault, like example, they call, this is the safety relay. This is the power 24 volt DC. This is the micro switch. If you cut off here, one line here, the power loss, open circuit here, we call open circuit fault. Or this is the same. You have here, and then you have here, you have a coil here, and then you cut here A, and then this one is open here, and the short circuit, short from one line to ground, to the ground. This is because short circuit to 0 volt. The third one is short to 24 volt. This one short to 24 volt from here, short to 24 volt. And then this is short contact. You can see here, this is short contact or welded contact. Example, welded contact, and when you press, contact is still not change status. We call the short contacts. Last one about the short circuit to circuit. For redundancy, we have 2 circuits, you see, between here and here. This is the short to circuit. This is short to contact. Okay, short contact, welded contact, and this is short to 24 volt. This is short to 0 volt. This is open circuit. All those kind of 5 types of the fault can be happen for the safety system. And if something happen, when you press emergency stop, some circuit, some category, the machine will not stop. This is the important. Some case machine will not stop because of some fault happen in the circuit. So you have to be careful about it to understand. about this. That's why I explained. For category 1, if you have the fault, this is the normal one. If you have the fault, for category 1, machine will, if something like this, if I put this smiling face, that means your machine still in safe state. Okay. If I put another face, like unhappy, machine in not in safe state. Safety 1, open circuit fault. Open circuit, is it fine? Still okay? Even open circuit. Because of the coil is dropped, right? How about this? When this is emergency stop, let's say. This is you have not pressed, and then another one is when you another one, even you press, this is from A to 0 volt. It's short like this. Is it still okay for to the category 1? And this one, okay or not? This one not okay, right? For category 1, you see, the system cannot detect because this one connect to this one, and the system don't know this is a coil. They don't know because this one is normal status. This is don't press, and when you press, have this one. When you press, still the same. The coil still energized, right? That's mean this one very dangerous to the people. When you have some shortage to 24 volt of the contacts here, when you press the button, you want to stop the machine, but machine not stop. You see, this is unsafe condition. Next, this one, and this one is the same, right? This one and this one still the same. For category 1, very dangerous when you design for category 1. So that means you need to consider other higher category. And for category 2, this is category 1. The definition required for category B apply well-tried safety component, but they don't have safety relay. For category 2, they don't have redundancies. Open circuit doing well, fine. They know system is cut off. For this one, is it cut off? Because safety relay. This is safety relay. You can see category 1. This is not safety relay. They have the normal relay. This is the coil. But if we change to A here, this is safety relay already. When this one connect to the safety relay, open, keep 5. This one, 5. But this one, this one system know or don't know? This one contact, this one because we have to apply 24 volt, right? You see? But if contact to ground, this is 0 volt, so they know. But if this one, we need 24 volt to supply here, but you have some short circuit to 24 volt, even you open this one, 24 volt still there, but machine not stop. Okay? And this one welded contact, still the same. This is dangerous as well for category 2. You see? If you don't understand, you can play the video or you can come to, you ask me after the this session. Category 3, fault, open circuit. They have double channel, right? Double channel here, double channel, one contact, two contact. If one channel fault, open, system can detect the fault. This is safe state, machine stop. And this one, if you don't press, this is also stop, right? And this one, about this. I put one more emoji here. You insert that here, machine still keep running. And then this is just like a worrying, worrying. Something happened, worrying. And then when open, They're worrying because from the category 2, category 1, they cannot detect, right? But category 3 keep worrying, but finally when you press, the machine is stopped because they have two channels. One channel is 24 volts still there, another one channel 0 volt. That means the system detect different of the voltage, and then machine will be safety relay will be, I guess, in false state and shut off the power. You understand what I mean here so far?
Yes.
Yes.
Okay, I try to explain in circuit diagram. I think if you are the electrician, you are electrical guy, you will understand in details. And next, the worry again, category 3, some short circuit here. When you press, no problem. System can detect in false state because this one 24 volt, this one 0 volt, not the same level of the voltage. That when system insists safety relay fault, one safety relay fault, it will cut off the power. And this one again, worry, something will happen if I press the emergency. Machine may not stop. When they open, is it stop? It's still okay, right? And then, but if only one fault, this one still okay because they monitor the level of this one. The level of this one is the same level of the voltage. But if they have something happen, we call accumulated fault, two fault after the first fault coming, something like this. Something like this. System don't know this one. You see, system act like the same is normal and cut off the system. But if you have accumulation of the undetected fault like this, what happened? Machine will not stop because the system, the first one, they don't know at the beginning that this one short circuit here, between here, they don't know, but they can, the safety function is still there. You understand what I mean? The safety function is still there, this one. When you open, they don't know this one. They don't know, the system don't know this one happened, but the system cut the power of the motor because of this one open. They know that this one open, both in the same time. It's okay, but they don't know this one happened. But if you keep this one happen, you will have some issue in the futures if you don't know about this short circuit. And then in next 2 days, you have short welded contact here. After this one short for a long time, and system don't know, never fault. And then once you have this one, and then you press emergency stop, you want to machine stop. In this case, machine will not stop. This is important. Will not stop. Will not stop because this one is they call accumulated fault. You understand what I mean? Because from here the circuit 24 volts still here and 24 volts still here as well, right?
Yes.
The system don't know. This is we call accumulation of undetected fault can be lead to the loss of safety function in category 3. In category 3, this is the gap of category 3. So category 3 again, if this one, in your case, you have many emergency stop like this. Emergency stop 1 or micro switch 1, card number 1, card number 2, card number 3, you series indicator, right? And then close loop back to the safety relay, something like this. And when you have the welded contact here, you see, something happen, worry, and then you open the emergency stop of this one, not this one. The system function properly, right? This one machine will be stopped properly because of 24 volt cut off from this system, and then it's emergency relay also know that 24 volt cut off in the same time. Okay, but this one still here, you see. And then this one, if you open this one, machine stop or not? This one
Stop.
Stop.
stop because of system detect the fault, right? This one have 24 volt. This one don't have 24 volt because cut off here. This one 24. And then this one 24, this one 0 volt. System detect this is not different of the signal. So system stop the fault because of redundancy system. So category 3 have, in conclusion, this is good. The category you can choose. Most of the control system for safety, they choose category 3, but they still have some gap of some accumulation of the fault, as I mentioned. Category 4, you can see category 4, they have some intelligence safety relay, but expensive. They have pulse. The power is generated by safety relay, not in the same time for both channels. One power for channel A, another power, another time for channel B. Because they don't send the same channel at the same time because of they want to check this is channel A, this is channel B, something like this. So if the open circuit, power or not, safe or not? Safe or not? If open circuit, safe, right? Because power, the check or found that this one and this one, they fall because of loss of this one, and this one still okay. Because this one, they checked this one and they lost. How about this? Also okay, right? They check this one. This is, I mean, okay mean machine stop. Okay? Okay mean machine will stop properly. Even we don't press the emergency. System will detect immediately. This is short to ground. This one not short to ground because they send the pulse. When they send the power, but this one 0 volt, they should get some signal when the power coming, but they don't get the power because 0 short to channel B, but channel A is still okay, and then they check, have the self check all the times. Even you don't press any emergency, they will put to the fault state, and in the fault state of the safety relay, and then they will stop the motor or cut off the magnetic contactor control system. What I mean, this one, okay, that's mean safe state can be there. And this one, they send the pulse, it got the 74 volt. But when you press, you got it, right? Pulse here, but this one here. This one is don't have pulse. They expect that when you press, you should have the same signal for both channel. But when you press, you don't get the same signal. Okay, signal A and B should be the same all the time. If not all the time, they will put to safe state, cut off the power to the motor. This one, when not press, the machine stop, and then when you press, it's okay, right? Because the both channel don't get the same signal. This one get 24, this one don't get. And this one, you expect to get the pulse, the signal, but you don't get. You check this one time, and you check this one time, and you don't get. You expect to get the signal, but you don't get. And this one will be in safe state, and system will be found. That means I put the smiling face here. Don't worry. This is category 4. Every fault, even accumulate, even this one in category 3. In category 3, short circuit from each channel. Category 3, they don't know, right? They cannot detect. But in category 4, they can detect as well. No issues. Any single fault or accumulated fault don't have any accumulated fault because they can detect every single fault at the beginning. This is category 4. In conclusion, all fault need to be detected for category 4, and power testing must be used. They use the power testing to the contacts and then come back to the system. And ECT input device must be independent input, as we mentioned. Any questions so far? 1 hour 37 minutes. Any questions? So this is the video that I collect from the YouTube. I'm not sure. Maybe we can play video. I think I need to play video with the sound. I can stop sharing and then come back with the sound. You can search. You can play again from yourself, and then I can play for you. And then to make example of the safety relay, how safety relay cut off with emergency, something like this. I will stop sharing first, and then sharing with sound. Sharing with sound. Sound include. Okay, share. Okay, I will play the video. This is the last slide. We have 91 slide, 92 slide, but I go quickly. But you can have a look again, and you can play the video as I mentioned the guy, but this is American, I guess, slang. So for me, it's Swedish slang.
I show this video.
You saw the video, okay. I will
Yeah.
play for other. You can explain to other as well if they don't understand. I will share this one. I will play now. I'm not sure how long of this video. We still have time, right, Tang?
Yes, we have time.
Hey Aditya, I heard that you got a package of
Wait a
42
minute.
LPA in our office and you just have a work experience of 3 years. How is that?
Hello, good day to everyone. Today let's see how a safety relay is functioning and how to install one correctly onto an electrical circuit. Even though the emergency stop is pressed, the contact weld at its normally closed contact points can be held in its closed position, allowing the machine to run continuously. This will create a dangerous situation, risking the life of the operator, and can also cause severe damage to the equipment. Safety relays can effectively isolate quite dangerous machines when a working contactor or relay is faulty. Today safety relays are manufactured with easy-to-install features such as push-in spring-loaded terminals. Here is a 4-pole circuit breaker for a conveyor motor, which requires a safety relay to be installed in its operating circuit. Shown here is a 2-pole circuit breaker for the control power circuit and safety relay. Then you have the emergency stop push button switch, the master relay, and the magnetic contactor. Safety relays need 2 or more relay contactors on their output side to monitor the feedback loop. Motor start stop push button switches and indicator lights are provided here. For the safety relay, you need a reset push button switch. Although optional, I have included an indicator light here to show that the safety relay outputs are in the off position. If the motor stops with this blue lamp on, you must check the safety relay to see the actual fault from its LED indicator lights. Before we wire up.
So from here, I mentioned about the safety relay, mentioned emergency stop, put button. They have 2 NC, normally close, and 1 NO. Normally this one, 2 NC will do the wiring for the safety relay, but NC will like a status to the PLC or some other system or output of this one, or the status of this button. And they have the reset button. When you press this one, normally the good system they will have, and then everything clear and then everything okay, you release this one to run the machines. The machine cannot run immediately. Normally you had to use the reset to reset the shift, because safety reset. In the circuit diagram, you need to connect this button for the safety reset before you back to run the machine again. And this is the normal one. Run, overload, and off, and put button start. This is start button. This is stop button. The normal of the DOL, direct online, to control the motor. This is the contactor with the overload here. And then you have the motor here. And then you have the incoming power. This is 3-phase power to connect connect to the circuit breaker, and this is control power, 24 volt to control power here. So they will explain you more.
Let's make the safety relay a bit bigger, so its terminals can be easily identified. Next, wire the motor with 3 phase lines through the 2 contactors. Coil ends A1 and A2 of the safety relay are wired with a 230 volt single phase supply through the 2-pole switch. Let's look at the operation manual of this safety relay for a moment. The supply voltage for this particular safety relay must be between 48 and 240 volts, AC or DC. For this relay, the S21 terminal must be connected to ground. Also, you should know that the input circuits, the start and reset circuit, and the feedback loop are powered by 24-volt DC voltage. Then joining S11 and S12 together will activate input channel 1, which in turn operates the internal contactor K1. Likewise, joining S21 and S22 together will activate input channel 2, which in turn operates the internal contactor K2. Y32 is for the PLC, that is Programmable Logic Controller input terminal. Let's go back to wiring work now. Connect S11 and S12 terminals through one set of NC contact points on the emergency stop switch. This is the input channel 1. Then connect S21 and S22 through the other set of NC
I come back
channel
a bit
1
for the circuit diagram.
and S12 programmable logic
From
control.
here, the circuit diagram, you can see this depends on the model of the safety relay. So this one is the input of safety relay is, they mentioned this is one AC or DC, but they use this one is the AC, as I mentioned, A1 and A2. They have power supply inside, but the safety circuit inside, they have 24-volt circuit inside for the feedback for themselves inside. And inside you see you input channel 1, input channel 2, and also the coil K1 and K2 inside. And that means this one can be used for category 3 at least. And also, I'm not sure they mentioned if specification can use category 4, this also can be, because they have the redundancies. But if the more intelligence, category 4 can be made. Next.
Solar input terminal. Let's go back to wiring work now. Connect S11 and S12 terminals through one set of NC contact points on the emergency stop switch. This is the input channel 1. Then connect S21 and S22 through the other set of NC contact terminals to enable input channel 2. Reset switch need to be wired in between S12 and S34 terminals, and also required to go through the 2 NC contact points on the 2 contactors. Terminals 13, 14, 23, 24, and 33-34 are safety contacts, which can be used to operate equipment safely. Output contact point 41, 42 is an auxiliary contact, which can be used only for display purposes. So we take 230 volt phase wire through terminals 13 and 14 and connect it to the A1 terminals of the 2 contactors. Connect neutral line to the A2 terminals. Connect control phase line to the indicator lamp through the terminals 41 and 42. Connect neutral line to. Wiring work on the motor start, stop and indication lamps are not shown here, since it has been discussed previously on the emergency stop switch wiring video. The LED indicator lights on the safety relay are enlarged here to make them more visible. To see the operation of this circuit, switch on the 4-pole breaker first. Master relay receives 3-phase power now. When the control circuit breaker is on, terminals A1, 13, and 41 receive power and the power LED is now on. At the same time, the NC auxiliary contact point 42 releases power to the display lamp on the panel board, and shows that the output power of the safety relay is still off. If the NC contacts on emergency stop switch are closed, input channel 1 is activated through closing of the terminals S11 and S12.
U.S. citizen, you can
Wait a
vote
minute.
from here,
Wait a second.
here, and even here. Using an absentee ballot, Americans who are traveling or living abroad have the right to vote from anywhere, whether by...
At the same time, input channel 2 is also activated via terminals S21 and S22. Now you can start the safety operation by pressing the reset button, which in turn passes 24 volts DC power to terminal S34 from terminal S12. Actually, reset LED indication light comes on when S34 is supplied with 24 volts. This will activate inner contactors K1 and K2, allowing normally open contacts at 13, 14, 23, 24, and 33, 34 to close. So, the LED indicator for the output is now on, and terminal 14 sends 230 volt control power to the motor run contactors. Before the reset button is released, the reset light goes out, because the start loop is now disturbed through the opening of the NC contacts on the contactors. Also, the motor starts running now, as the contactors are with the control power on. Further, terminal 42 has no power now, so the output shutdown light is off. If you press the emergency stop button now, input channels 1 and 2 are deactivated. The LED lights for those two channels are off now. Terminal 14 is no longer receiving 230 volts, so both contactors cut three-phase power to the motor. Terminal 42 receives power at the same time, and lights the indicator lamp on the panel board. Fault indicating red LED will not light up here, because both input channels are turned off simultaneously. The operation can start again by first resetting the emergency stop button, and then pressing the reset button. Let's see another operating condition of the emergency stop switch now. Here you can see that the upper NC contacts have a welded condition. Input channel 1 is deactivated here, because the lower NC contacts have opened up correctly. So the output turned off, and the motor comes to a safe stop without any problem. But the fault indicating red LED has now lit up, since input channel 2 did not turn off simultaneously.
This is what I mentioned about the fault, the welded contact here. This is the short contact to one contact, and another contact still is okay. But the system, the safety relay can detect the fault.
Also, you will see that the LED light indication on input channel 2 is now flashing, with the red LED fault indication lit up continuously. The system cannot be reset until you correct the fault on input channel 2 by replacing the faulty emergency stop switch with a good one. Also, if any contactor on the output side has a faulty condition due to contact welding, it will not be possible to reset the safety relay. Since the reset loop is connected via the NC contact points on the output side contactors, any open NC contact in the loop will prevent resetting of the safety relay. So you need to attend to the fault and replace the faulty contactor before resetting the safety system back to normal. I hope you have a good understanding now of how safety relays.
Hello, Banjob. I have the question. In the catalysis 3 and 4, can we use the normal emergency stop like which have the two channel? Also, we need to have the specific emergency stop device.
Actually, emergency stop you can have if you have at least two channels. If you don't have any signal to PLC to monitor, you can use the what you have emergency stop. But emergency stop, most of in the market must meet the standard of emergency stop. But you need to contact normally
yes.
closed. Normally closed. It's okay.
Okay.
The key is about safety relay. Most of the safety relay, or you have most of the plan that I found, you use only one channel of the safety device. The example for emergency, you use only one
Yeah.
channel, and then connect to maybe safety relay, but you connect only one channel. But your risk there, if you do the assessment around D or E, so that means D or E, you must select like a category 3 at least, right? If E, like moving device, something like this. So in conclusion, you must understand about to do your risk assessment. This is the basic that I mentioned example. You have to do you have to do the assessment before you design, you select the equipment, or you already have existing machines, and then you come to see that, hey, what is the risk level here? You can check about how serious if accident happen, how often people need to come to these machines or inside for the moving part, and how probability of the to protect to avoid the risk. You answer this one, S1 F1 or F1 F S1 F2 F1 F2 P1 P2, and then you get the level A until E. If you got after you got, and then you select which category that you need to design to meet the level E. The example, the table that I show you for E, that means you need to select the category 3 in the minimum. And then for the fault, why I show you the fault? Because I want you to understand the difference of each category and each safety relay compared to normal relay. And then you know about the some the risk if you select the wrong equipment, or if you don't follow the circuit, something like this. And also the safety component, you can check from the safety data sheet. Is it meet your requirement or not per your assessment? Do the assessment by yourself, select category from the table, and then make sure that when you do the design and circuit diagram, you make the right circuit. You have the feedback and reset monitoring system, redundancy, something like this. Okay. I think I speak alone. Just only some or two guy feedback to me. I'm not sure. Thắng and another guy I heard
Hello,
some
hello,
answer.
Banjob.
Sun.
Can you
Okay.
hear me? Okay.
Yes, Sun.
Okay. Thank you so much, Banjob, for giving us a wonderful opportunity today to understand clear about the safety electrical equipment. So
Yeah.
after finish training, can you send to us a list of electrical component, Mr. Sankman standard, also the
Yeah.
brand name for us apply for the natural test?
Yeah. I have not only safety, I have all control system. But for the update one, I am not sure. But the same version that I share to Jibrok, I share to VTI South,
Okay.
and also HPC. I will share to Tang, and Tang can distribute to every people again.
Okay. Thank you so
I
much.
have all.
Okay.
You're welcome.
Okay, thank you, Banjob. I think now you can take a rest time. I will
Okay,
continue.
you can switch to Vietnamese, and then I will
Yes.
leave, and then you can we can exchange the document, and then you can distribute to the team. I can share you the presentation and additional document that Sun asked me about the standard from Saint-Gobain for control system. Or everything I have. This is, I think, in 2016 that I got this one. I haven't got the new one, so you can follow the standard, including even electrical wiring, electrical cable tray, cable, or everything about the control system automation. I will share.
Okay, thank you.
All right. Have a good day, Jim. See you in Vietnam. Bye bye.
Thank you.
Bye bye. You are welcome. Bye bye.
Dạ, vậy thì giờ em sẽ bắt tiếp tục cái phần của mình hôm nay ha. Em biết là trước khi bắt đầu thì mọi người có câu hỏi nào không ta? Hello.
Thắng ơi.
Dạ.
Thắng có mấy con relay lúc nãy á, thì anh thấy nhà máy hầu hết là nhà máy Phương là không có Thắng ơi. Thì cái này không
Dạ.
biết là sau này những dự án mình sẽ update hay là bắt đầu từ mình phải có cái nâng cấp dần ha.
Dạ, vậy lát tới phần sau thì mình sẽ nói cái phần đó anh sao?
Ok.
Ok, vậy thôi vậy để em bắt đầu luôn ha. Thì tiếp theo là em sẽ về cái tiêu chuẩn mà trên safety của Saint-Gobain mình nó yêu cầu ha. Thì đầu tiên thì mọi người thấy đây một cái slide về đánh risk assessment của mình. Thì đây mọi người quá quen thuộc với cái này rồi. Thì rủi ro bằng cái mức độ nghiêm trọng và nhân xác suất thì cái đây là mình đã thực hiện rất là nhiều rồi. Thì ở đây thì nó có trong tiêu chuẩn machine safety thì nó sẽ có một cái yêu cầu như thế này. Đây mọi người sẽ thấy là nó sẽ phân làm 4 loại rủi ro từ thấp, trung bình, cao và rất cao. Thì nó sẽ tùy theo số điểm mà mình ở đây mình sẽ quan tâm tới cái việc là từ 210 điểm là cái rủi ro rất cao. Thì trong cái tiêu chuẩn machine safety của mình đó, ở đây á, thì nó sẽ có quy định rõ ràng luôn, là tại vì hồi nãy giờ mọi người nghe mọi người cũng giờ cũng không hình dung là khi nào mình sử dụng PL gì. Thì trong tiêu chuẩn của safety của mình nó có quy định sẵn rồi. Thì cho những cái rủi ro cao, phần mà critical á là mình ít, cái mọi người sẽ nhìn cái bên bên cái cột này ha. Thì cái phần mà design của mình với cái performance level của mình ít nhất là phải đạt là catalysis 3 và BLD. Rồi cái phần very critical nó cũng tương đương là ít nhất là cái phần, nếu khi mình đánh giá rủi ro mình thấy cái điểm của mình về trên safety nó từ 210 điểm trở lên thì mình phải áp dụng là catalysis 3 và BLD. Rồi tới đây mọi người có rõ mà. Rồi em sẽ đi tiếp nha. Thì khi mà mình ở đây nó chỉ thêm một cái slide nó thêm để nó nói về cái việc mà khi mà mình có những cái biện pháp kiểm soát rủi ro thì phải tái đánh giá rủi ro lại. Thì tiếp theo là em sẽ show cái tool của cái machine safety để nó đánh giá về cái vòng đời của cái sản phẩm, vòng đời của cái máy mình. Thì nó đánh như thế nào ha. Đó thì mọi người ở đây cái tài liệu này thì anh là ở trên cái machine safety thì cái này các em cũng có dịch ra một số cái dịch ra tiếng Việt để cho mọi người dễ hình dung hơn trong buổi này. Thì này lát em sẽ gửi lại. Thì ở đây là mọi người mới thấy bên tay phải là một cái tool, cái này cái file Excel, để lát em sẽ mở cái file Excel lên cho mọi người dễ hình dung. Thì là nó sẽ để nó đánh được mọi người thấy này, từ nó nguyên cái dòng đời của cái máy, từ cái lúc vận chuyển đến cái lúc lắp ráp, commissioning, troubleshooting, maintenance gì đó là nó sẽ có tất cả ở trong đây. Thì để mình thực hiện đánh giá rủi ro cho cái máy ha. Rồi thì mọi người thấy ở đây là cái file cái trên slide thôi. Lát em sẽ show cái phần cái file Excel cho mọi người dễ hình dung. Thì ở đây mọi người thấy là ở đây nó đánh là ví dụ như là về cái công việc này là nó đang đánh cái quy trình là setting up của cái máy. Thì cái rủi ro nó là gì, một rủi ro về cơ khí, về cái đó, về cái severity là nó medium, nó low, nó high gì đó. Rồi xong tiếp theo là cái probability thì very high, nếu mình đánh ở đây thì nó sẽ tự động ra cái điểm là 210 là critical. Thì khi 210 đó thì nó sẽ quy định mình sẽ phải làm những cái gì. Thì mọi người thấy ở đây ha, tiếp theo mọi người thấy ở đây thì ở đây á, là cho cái điểm 210 này thì nó mandatory là mình phải cái phần design của mình đó là phải catalog 3 và BOD. Rồi tới phần này mọi người có nắm được chưa ạ?
Chưa hiểu lắm Thắng ơi, cái này chắc phải có cái file Excel xem graphic thế nào luôn.
Dạ. Thì đây anh Thì ví dụ như ở đây là em lấy một cái ví dụ ha. Thì cái này là cái tool của machine safety ha, rồi nó về nó đánh giá cái risk assessment cho cái vòng đời của cái máy. Thì đầu tiên nó cũng là những thông tin cơ bản về ngày đánh giá, rồi workshop, rồi location gì đó, rồi machine ID. Rồi, thì tiếp theo ví dụ như đây là mình sẽ đánh giá cho một cái task công việc cho cái phần mà maintenance của mình ha. Thì
cái này để em tên cái tức là cái này là
anh nói nó không nghe đâu, mọi người không nghe đâu. Anh bật mic anh đi.
Mút đi nha.
Cái em mở lại cái file share read assessment nãy không thì để em xem. Cái này nó không có gì mà nó bình thường như là cái đánh giá rủi ro của em á nha Sơn ơi. Tức là khi mà để được 210 điểm thì nó lấy cái tần suất nhanh cho hậu quả trong cái file read assessment á, để nó ra được là 210 hay là 48. Thì khi mà em xác định cái ví dụ cái hàng rào, cái thiết bị đó là critical risk, tức là cái điểm từ 600 cho tới 1000, thì em sẽ có hai giải pháp. Giải pháp đầu tiên của em đó là fix gạt, là ưu tiên hàng đầu, tức là em sẽ dùng những cái hàng rào cứng của em có bu lông để em fix vô, thì cái đấy đó là giải pháp hàng đầu. Trong trường hợp em không làm được cái hàng rào đó thì em mới suy nghĩ tới cái thiết bị safety interlock, thì lúc đó mới theo safety interlock rồi thì em mới ứng là 200 critical risk, thì em theo là PCI CAT level 3. Còn nếu mà level 4, còn critical tức là từ 210 tới 600 thì em qua category 3. Còn rồi đến là medium là từ 48 thì đến 210 tức là màu vàng em mới qua category 2. Thì nó ứng với cái file này, nó thể hiện cho em rất là rõ nó như vậy thôi. Cho nên á, ưu tiên hàng đầu của mình vẫn là fix hàng rào cứng. Sau khi không làm được cái hàng rào cứng rồi mà tụi em muốn suy nghĩ cho cái vấn đề interlock thì tụi em sẽ đi theo cái hướng của interlock này. Còn cái việc đánh giá rủi ro làm sao ra được 210 hay làm sao ra được 600, y chang như cái tool risk assessment hiện tại mình đang dùng, nó simple như vậy thôi. Đấy. Thì như nãy anh có hỏi Banjob là vậy khi nào thì dùng fixed guard, khi nào mới lắp thêm cái con interlock safety device này, thì trong tiêu chuẩn nó nói rất là rõ rồi. Khi nào mà chúng ta không thể sử dụng cái fixed guard á, thì chúng ta mới dùng tới những cái safety interlock bao gồm có sensor hay là curtain light ABCD, thì mỗi cái nó đi theo cái này. Còn nếu mà em đã dùng được fixed guard rồi thì lúc đó em không cần dùng cái curtain sensor nữa. Đó là cái mà team lưu ý. Có trường hợp em vừa dùng cả vừa dùng cả cái curtain, cái sensor safety sensor và cái fixed guard. Trong trường hợp nào? Trong trường hợp cái hàng rào đó tụi em phải daily operation, nó vô ra một cách liên tục mà tụi em không thể đóng mở được
Đừng
cái bu
chó
lông,
6
lúc
cái
đó
yêu anh đấy nhá. 15
thì
của anh,
lúc
6 cái mục anh vừa đưa.
thì lúc đó em mới cần phải dùng kết hợp cả hai. Còn trong trường hợp mà chỉ dùng cho bảo trì, ngày bảo trì vô không á, thì đương nhiên tụi em nên fit hàng rào luôn và quên đi cái con sensor safety. Mọi người cần nắm rất là rõ cái này, chứ không phải cái nào cũng vừa phải có hàng rào cứng mà vừa có cái sensor đâu nha. Ok, Thắng không ý mọi người có câu hỏi nào cho cái này không? Cái này cái chính đó nha, chứ không phải cứ lắp càng nhiều càng tốt đâu nha. Ok ông Sơn ơi.
Em hiểu sơ đồ đàn, tuy nhiên thì làm sao để mình chọn được là khu vực đó mình làm một con sensor nào á. Tức là ví dụ như là mình phải đánh giá rủi ro hết toàn bộ lại các thiết bị của nhà máy mình là theo cái file này anh hả? Hay là mình đâu có dùng kết thừa được cái file toàn bộ risk assessment sau các bản chốt của nhà máy đâu, mình phải đánh giá lại theo cái file này.
Cái này á, trong trường hợp mà em tự tin được cái bản đánh giá rủi ro cũ của cái file của em á, tức là em đi đánh giá, tại vì cái này gọi là Machine Safety Audit nha. Machine Safety Audit tức là gì? Em đánh giá trên cái thiết bị đó. coi thử những cái thiết bị moving nó có những cái bao che đồ đầy đủ hay không, để mà em confirm lại cho những cái gạt đinh nè, những cái con sensor của em nó đang ok hay không, nó đang read bao nhiêu và nó có ok hay không. Nó khác với cái read assessment trên cái file mà tool của mình, tức là read assessment của em nó bay trên một cái tab tụi em đi đánh giá, có thể là tab bảo trì, có thể là tab sản xuất. Còn đối với cái file read assessment giống này, nó đánh giá về mặt physical asset, tức là em đánh giá về mặt cái thiết bị đó, những cái chức năng, những cái hàng rào, những con sensor, hay là đã đủ để đảm bảo an toàn cho người nào tiếp xúc hay chưa. Em hình dung không? Hai cái nó khác nhau.
Cái này chỉ thiên về kỹ thuật thôi, và team kỹ thuật á, team mà champion của Vietjet Safety á, sẽ tới từng thiết bị và đánh giá cho phần an toàn thiết bị thôi, chứ không cụ thể liên quan tới một cái chốt hay một cái tab của vận hành hay bảo trì nào cả, để mình đưa ra giải pháp là nào là được chỗ đó là hàng rào hay là đất xem lai cơ tình hay sensor gì đó thôi ha.
Đúng. Chính xác, hoàn toàn chính xác. Đúng rồi.
Rồi thì em đi tiếp, em đi nhanh qua cái file này ha, thì để mọi người cứ thì ví dụ như ở đây là mình nói đang có công việc bảo trì của mình là mình thay thế một cái bạc bị mòn, thì cái rủi ro gì, rủi ro về những cái vật quay, rồi có thể các khả năng bị cắt, bị đứt tay gì đó, thì mình đánh ở đây là cái security severity là 2, cái tần suất là medium, thì nó sẽ ra để mình hai cái điểm là 240, thì cái này nó tự động nó tính ở đây, thì mình chỉ chọn thôi. Dù chọn medium, nhưng medium này thì nó sẽ ra 126, thì nó tương ứng với cái file đánh giá RAW của mọi người đang làm thôi, chứ nó không khác gì hết. Ví dụ như này 2 đi ha, thì ở đây á mọi người sẽ qua bên này sẽ thấy cái file nó sẽ tự động nó điền là cái mandatory, cái engineering control này nó mandatory, thì đó cái nó sẽ yêu cầu là mình cái control reliable của mình đó là catalog 3 và BLD. Nhưng mà ở đây thì nó ví dụ như mình đã, như anh Sơn nãy vừa nói, là cái việc là nếu mà mình lắp được một cái phích gạt đinh, thì mình đã, sau khi mà mình lắp được cái phích gạt đinh, mình đánh giá rủi ro lại mà cho cái thiết bị nó đã thấp rồi, thì mình sẽ không cần là đến đến cái việc mà mình lắp những cái thiết bị sensor như lốc lan tư tình gì đó, thì thôi là mình đánh giá xong sau đó mình đưa giải pháp, và nếu giải pháp sau khi giải pháp thì mình đã đánh giá lại để mình coi cái điểm. Không, tương tự như mấy cái file mà mọi người đang làm thôi, nhưng mà nó này nó chuyên về cho cái mà chỉ safety để nó đánh nguyên cái dòng đời của một cái máy. Thì em đi lướt nhanh một cái ha, thì ở đây nó cũng có một cái ví dụ của của Rock ha, về nó để nó sử dụng cái tool nó để đánh giá rủi ro cho cái ví dụ đây là cái máy mình có một cái vít tải ha, để chuyển cái nguyên liệu từ vô cái họng này để chuyển đi, thì nó sẽ đánh giá như thế nào ha. Đó thì mọi người thấy ở đây nó sẽ đánh giá, nó dựa vào 4 cái, ví dụ như user limit là giới hạn về sử dụng, giới hạn về không gian, giới hạn về thời gian gì đó, về những cái giới hạn khác, thì nó đưa ra một số những cái giới hạn ở đây. Mọi người có thể sẽ gọi là cái file này để mọi người có study sau để mà lướt nhanh cái phần này thôi. Ví dụ cái tác công việc ở đây là ví dụ nó đánh giá cho một cái tác công việc ha, là nó có là cái anh này anh sẽ là anh vận hành anh phải là đổ nạp cái nguyên liệu vào cái tải này, những cái điểm này, thì có cái vùng nguy hiểm là nó sẽ có cái trục vết tải và cái thân của cái vết tải đó. Thì mọi người thấy ví dụ như mình đã đánh ở đây, đánh rủi ro cho cái đầu mục đó ha, ví dụ tương ứng là 320 với 800 điểm. Thì ở đây mọi người sẽ thấy cuối cùng là nó sẽ ra một cái nó sẽ ra một cái giải pháp là lắp cái gạch bao che cố định cho cái việc mà để tránh cái việc công nhân mà tiếp xúc với cái trục vết tải này. Thì ở đây là nó sẽ lấy rồi, rồi sau khi thì cái này cũng như là cái file Excel hồi nãy thôi, em bỏ vô đây cho mọi người dễ hình dung thôi. Sau khi mình lắp cái fix gap thì nó sẽ cái điểm rủi ro nó sẽ giảm như thế nào. Rồi thì em sẽ đi về một cái tiếp theo là về một cái ví dụ mẫu ha. Cái này thì cái hệ robot ở nhà máy Hiệp Phú thì cái này là cũng được nhà anh Banjob anh một lần anh review về cái hệ này rồi. Thì mọi người thấy ở đây là cái con robot này có chức năng là sẽ gấp tấm ở trên cái băng tải này để nó ship vào ba cái chồng. Thì mình ở đây có một cái khoảng rất trống. Nãy mình nói là cái trường hợp mình lắp được cái fit gạt thì nó ok rồi. Còn ví dụ như trường hợp này là mình sẽ không thể nào mà lắp được fit gạt này, tại vì xe nâng này sẽ đi ra vào lấy những cái chồng tắm này liên tục. Thì cái giải pháp của mình là sẽ lắp những cái thiết bị an toàn phù hợp để mình giảm thiểu cái rủi ro cho cái con robot này ha. Thì ở đây sẽ có một số cái thiết bị an toàn như cái safety light curtain. Thì cái safety light curtain đây ở đây bên đây nó sẽ là một cặp này ở phía này, từ phía đây qua đây. Tiếp theo là cái safety scanner. Thì mọi người thấy là cái con light curtain đây thì nó chỉ bắt được là từ khoảng này qua này. Đó thì con safety scanner này nó có nhiệm vụ nó bắt cái vùng dưới đây. Đó. Rồi một số cũng ở đây thì cũng sẽ có một cái cửa để vào, tại vì ở đây là cái tủ điện của cái con robot này nó nằm ở phía cái thân robot này nè. Thì khi mà mình vào mình bảo trì hoặc mình reset robot gì đó mình phải mở cái cửa này. Thì ở đây cũng là một cái rủi ro này. Mình khi mà đánh giá thì cũng lắp thêm một cái safety door switch ở đây. Rồi thì nhắc lại xíu thì mọi người nhớ là ở đây là theo cái tiêu chuẩn mà safety của mình là yêu cầu là tối thiểu là catalog 3 ha, BOD. Rồi thì khi mà vô về phần mà cái device, những cái device thì đầu tiên là mình sẽ đi vào cái con robot. Cái con robot này thì nó đã được thiết kế nguyên giống như là một cái combo rồi. Thì khi mình mua thì mình sẽ kiểm tra những cái chức năng an toàn của nó. Thì ở đây thì nó đã design theo cái category 3 và performance level. Rồi tiếp theo mình sẽ check từng thiết bị ha. Thì về là safety light curtain thì ở đây mọi người có thể cái này mọi người có thể dễ dàng để kiểm tra ở trên cái manual của cái thiết bị hoặc là trên website của cái hãng. Thì đây là catalog 4 VOD VOE. Đây thì scanner, tiếp theo tới scanner rồi tới safety door switch thì cũng đây là cũng tương ứng ha. Thì tất tật những cái thiết bị hồi nãy là light curtain, safety door switch, safety scanner gì đó sẽ đưa hết tín hiệu về cái con safety relay. Ở đây safety relay thì nó cũng sẽ có cái catalog với bộ performance level của nó ha, tương ứng. Thì ở đây thì cái phần này nó tiếp theo cái phần điều khiển ha. Thì cái này cũng sẽ hơi khó hiểu xíu, mọi người chịu khó. Thì như hồi nãy là anh ba chớp anh có chia sẻ là tất cả các thiết bị an toàn của mình, công tắc cửa này kia là mình sẽ đưa về con safety relay. Đó. Thì ở đây sẽ một cái con công tắc cửa này sẽ có hai cái output an toàn, nó gọi là output safety á, sẽ đưa về con safety relay, đưa về input của safety relay. Đó. Thì tất tần tật những cái output của safety relay này sẽ được nó sẽ đấu nối tiếp với nhau và nó đưa về nó kết nối vào về cái tủ con robot này. Cuối cùng thì mọi người sẽ thấy ở đây đây là cái mạch điều khiển của cái con robot ha. Khi robot người ta design này để người ta đã chuẩn bị sẵn cho mình hai cái chân để làm cái air stop. Thì mình sẽ kết nối từ đây một hai đây ha, một đây ha, một này đi qua tất cả con safety relay để về chân số 2. Còn cái chân số 19 này 19 là bắt đầu từ đây ha, để nó sẽ qua tất cả safety relay thì nó sẽ quay về số 20. Rồi cái phần mình đi tới phần cuối cùng phần snapshot thì theo theo em nghĩ á, thì do mình nên là làm cái demo của cái loại safety cái phần này. Tại sao? Ví dụ sai anh Sơn là thì khi mà vừa rồi cái đợt audit vừa rồi á, thì gần như là chưa có cái con safety delay nào nó sai luôn, nhưng mà một số cái vị trí mình cũng đang là lắp những safety delay cái tầng này. Thì em nghĩ là mình nên làm demo một cái vị trí dựa vào cái file reassessment, và dựa vào cái những những gì nãy giờ anh Banjob cũng có chia sẻ. Rồi thì mình có thể là như nãy mà anh Banjob có nói rồi ha, thì có thể mình book một cái buổi offline tại site, ví dụ một số nhà máy như VTI, HBC của site của anh Sơn. Mình có thể book offline tại site để mình có thể hiểu rõ hơn cho những các bạn về kỹ sư điện, về kỹ sư về bạn mà chơi safety thì bạn sẽ hiểu rõ hơn về cái này. Thì em nghĩ là mình nên là review lại là cái tiêu chuẩn về safety của mình. Thì nếu có những cái thiết bị, những cái máy nào mình chưa có đáp ứng tiêu chuẩn á, thì mình cần có plan để mình correct nó lại ha. Thì theo theo em nghĩ á, về thiết bị á, là mọi người sẽ rất là dễ chọn. Về safety light curtain, safety sensor này, về safety delay thì sẽ rất dễ chọn. Tại vì nó khi mà nó bán hàng á, thì mình chỉ cần hỏi một cái anh bán hàng là anh có thể là đáp ứng được cho mình là cái BLD catalysis 3 rồi, thì rất là đơn giản. Nhưng mà cái phần khó nhất là cái phần cái mạch điều khiển và cái mạch động lực như thế nào thì sẽ đúng. Thì nếu mà khi mình không chắc chắn, mình không ấy, mình có thể mình gửi cho anh Banjob để anh sẽ giúp mình, anh review lại, rồi sau đó mình có thể là apply ra những cái máy giống nhau, tương tự như nhau. Phần cuối cùng ha, thì ờ, hồi nãy giờ mình đang nói phần cái internal không à, bây giờ là cái phần external thì về những cái nhà thầu, những cái người mà thực thi những cái dự án lắp đặt máy cho mình, design máy cho mình, thì họ cũng phải nên biết những cái yêu cầu này. Thì mọi người, các machine safety chamber nên áp cái tiêu chuẩn này vào trong cái phần mà scope of work, về cái phần tiêu chuẩn máy móc thiết bị, tiêu chuẩn machine safety của site, để khi mình gửi cái scope of work đi, mình sẽ đính kèm vào cái này vào, để đảm bảo là khi cái máy nó từ quá trình lắp đặt, nó đã từ quá trình nó thiết kế, nó đã đúng rồi. Thì phần của em thì nó cũng hết rồi. Thì mấy anh em mình có thể là giờ thể trao đổi những cái nào mọi người từ đầu buổi tới giờ mọi người còn vướng, mọi người chưa có nắm được, thì mình có thể trao đổi ha.
Thắng ơi,
Dạ.
lúc nãy anh có chia sẻ, ông Banjob ông sẽ gửi lại cho em cái file ông update mới nhất về các clip thiết bị liên quan đến an toàn ông chia sẻ. Thì anh nghĩ rằng dựa theo cái list đó thì mình và một số brand name ổng recommendation á, thì mình dựa theo đó để mình chọn luôn, sau này mình dùng cho nhà máy mình cho việc nâng cấp cũng như là cấp giá.
Ờ, anh Sơn, theo ý em nha, là
Ừ.
cái list đó thì anh có thể là anh gửi anh tham khảo được, nhưng mà nó sẽ không phù hợp với từng site đâu. Tại vì á, ví dụ giờ anh có thể là sử dụng IFM, anh có thể sử dụng SIG, anh có thể sử dụng Pills, nhưng mà nó chủ yếu là nó phù hợp với tiêu chuẩn là được. Giống như hồi nãy cái phần mà em share về về cái device đó, có thể check rất là đơn giản. Có thể là anh cần contact với hãng để họ cung cấp những cái catalog, cái manual để mình check lại thôi à. Chứ bây giờ nếu mà ảnh đưa một cái specific về cái device như vậy á, khi anh triển khai nó sẽ khó cho anh hơn nữa.
Ok. Ok, vậy thì em gửi cho anh lại cái file em mới design á, hàng file standard của nó. Thì anh involve bạn một cái team bên anh, thì bạn là cơ khí, thì nhớ hơn một cái liên quan đến điện thì bạn sẽ involve các kỹ sư điện vào để hỗ trợ bạn chết đúng cái catalog nhu cầu ấy.
Dạ. Theo em cái phần mà chọn thiết bị thì nó không có khó lắm, nhưng mà phần khó nhất là cái phần của mạch điều khiển. Tại vì từng cái máy nó sẽ khác nhau. Ví dụ như nãy nói nó ví dụ như một cái máy lúc nào phải có hai interlock phải double hết, là hai cái contactor nó đấu nối tiếp nhau, thì bây giờ cái máy anh đã lắp đặt rồi thì làm sao mà anh lắp thêm một contactor để nó nối tiếp được, thì cái phần đó nó sẽ rất là khó để làm hơn là cái việc mình chọn thiết bị.
Anh có một cái này nè Thắng, là anh không có ensure là tất cả những cái bạn kỹ sư đang ngồi ở đây mà tham gia, có bạn thì tập trung, có bạn thì không tập trung, có bạn đã từng làm, có bạn chưa từng làm. Anh chưa nói là mình có làm theo những cái gì của ban job nói hay không, nhưng mà tối thiểu là phải đảm bảo cái team mình phải hiểu được cái đã. Mình chưa nói là mình có chi phí để mình làm hay không, trước nhất là các bạn phải hiểu cái đã. Thì anh Paul á, là em work tiếp với Banjob cho một cái topic nữa offline cụ thể, có thể mua thiết bị đồ về, mình pilot cho các bạn biết ok cái này là ở level là critical risk là thiết bị này, cái này ở level là critical thiết bị giống vậy, và ở cái này ở medium thiết bị giống vậy, và cách đấu nối là phải như vậy đó. Thì bắt đầu mình làm một lần như vậy, gọi một số bạn kỹ sư gom lại làm, và ban job đấu có thể đấu trên mô phỏng và đấu thực tế gì đó, em bàn với ban job và mình làm như vậy. Thì anh muốn phải thực tế như vậy, đó là cái thứ nhất, về mặt kiến thức. Cái thứ hai nữa là ở đây có những người rất là quan trọng, ví dụ anh Cường nè, ông Chức nè, ngoài anh Chức thì ít, nhưng mà ở đây không có anh Kiên nhưng mà có ông Thương nè, đấy, hay là ông Hà nè. Thì các bạn phải hình dung là cái margin safety nó có 3 level, nhưng mà level mà cao nhất của margin gạch đinh đó là hàng rào cứng nha, hàng rào cứng là cái level cao nhất. Còn những cái safety device như là sensor curtain nó chỉ thay thế hàng rào cứng khi mà chúng ta không thể lắp hàng rào cứng thôi. Đó là cái thứ nhất. Tại sao nó như vậy? Cái thứ nhất bởi cái việc mà chi phí đầu tư nó lớn. Cái thứ hai là bảo trì bảo dưỡng nó rất là phức tạp. Cái thứ ba nữa là cái việc đấu nối nó cũng rất là khó, và nó không thể nào mà trọn vẹn bằng cái hàng rào cứng cả. Do đó là các bạn phải biết cái thứ tự ưu tiên như vậy. Một cái thứ ba nữa là các bạn đừng có nghĩ bao giờ là đã có hàng rào cứng lắp thêm một cái sensor cho nó chắc, để nhân viên lỡ không khóa có cái sensor. Mình đừng có nghĩ như vậy. Tại vì các bạn mà lắp như vậy á, là người công nhân á, họ cứ nghĩ vào có con sensor rồi bắt đầu họ rely luôn. Và Sơn đã gặp nhiều trường hợp ở nhà máy rồi, ví dụ nhà máy của Vita sao nhiều anh em qua kéo cái hàng rào lên kêu là đây đã có cái con sensor nó tự tắt rồi thì cần gì phải ấy. Cho nên các bạn phải rất là rõ ràng, cái nào đã hàng rào cứng rồi thì là bỏ cái con đó đi, chứ không phải rồi vừa hàng rào cứng rồi vừa cái kia, rồi dẫn đến cho nhân viên cứ kéo cái cửa ra cái là lóc. Thì các bạn phải coi lại những cái trường hợp này cực kỳ là seriously. Cái margin safety nếu mà chưa rõ thì raise hand lên, có một buổi workshop nữa cho cái vấn đề này, chứ không phải vô tội vạ đi gắn những cái con sensor ở các cửa ra vào rồi kéo cái cửa ra một cái dừng rồi đi vô, kéo cái cửa ra một cái rồi dừng đi vô, làm cho nhân viên nó lầm tưởng là cái đó là một cái được cho phép và an toàn, dẫn đến có khi nó không lô tô khi nó làm luôn, chứ đừng nói nó vào để mà nó ngó nó nhìn nữa. Do đó là cái này là cái mà chúng ta cần phải chấm dứt trong thời gian tới. Một số nhà máy đang rất là phát triển đại trà cái này luôn á. Hiệp Phú là một này, Vita sao là hai này, HBC Vico là ba này, Vita nó là 4 nè, nhiều vô kể luôn, đặc biệt là HBC và Vita sao. Hương ơi, alo. Thì thôi thì, chia sẻ mọi người như vậy để mọi
có
người
em nè anh Sơn có em nè.
ấy thì anh chia sẻ rất là rõ ràng và rất là thẳng thắn, anh cũng chẳng ngại ngùng gì, bởi vì cái này là thực tế nó đang diễn ra như vậy. Mình phải rất là cẩn thận, chứ không mình lắp đại trà rồi 3-4 năm nữa nó hư hỏng, bảo trì không hiệu quả là chết. Chưa kể viết lắp có đúng theo quy trình. Thì team lưu ý cái này, cho nên cái này là anh đề xuất là Thắng phải làm một cách triệt để luôn để đảm bảo mọi người biết
để khi mà lắp sensor đi qua là phải qua những cái ông ngồi đây, ông confirm ông coi có nên lắp hay không lắp, chứ không phải cứ có tai nạn xong là lắp đại trà đâu. Thì hy vọng là mọi người cũng đồng ý cái quan điểm này với Sơn. Chỗ Cường không biết ở đây có bạn bên Hiệp Phú có ai không? Ok, Hiệp Phú không có ai không? Ok ông Sơn ơi,
Đồng ý anh Sơn ơi.
ok thì anh nghĩ Hải Phòng rồi thì cũng thành vấn đề, Hồ Chí Minh nó ít, nhưng mà Hiệp Phú với Vi Tài là rất là nhiều mấy cái này, cho nên mình phải thống nhất vậy.
Ở bên em ít xài thêm sensor lắm, đa phần nó dùng luôn cái cũ, nó ok hết.
Đúng rồi, đúng rồi. Ok thôi, ông có gì nữa thì Thắng coi next step của mình là gì. Anh muốn mọi người ở đây phải thật hiểu, chứ không phải hiểu lâm cơm rồi xong bữa hôm nay rồi tuần 2 tuần sau lại quên.
Mà có comment thêm chút là hồi xưa em đã từng học cái machine safety dạng dạng này rồi ấy, nó phải thực hành là sai phải tầm 4-5 buổi nó mới hiểu, chứ ngồi trong này nghe online chắc chưa ai hiểu mấy đâu.
Anh biết chắc chắn không hiểu đâu, cho nên giờ phải kêu Banjob qua mua thiết bị về tổ chức workshop nào cho mọi người đấu thử.
Bảo trì và OB.
Đó, anh nghĩ next step phải như vậy. Ok Thắng work tiếp nha Thắng.
Ok rồi, cảm ơn mọi người mấy anh, cảm ơn mọi người. Thank you Thắng nhá.
Bye.